Hello and welcome. Today we will talk about data science, a topic that has been a buzzword for the last several years. Joining me in this conversation is Praveen Satyadev. Praveen has more than 18 years of experience into digital space, be it digital marketing, digital analytics, so on and forth. He's based out of London, and I'm very glad to have him with us today. Praveen, I'm sure I haven't done justice to your intro. Would you like to take a shot?
No, I think you did a great job. But thank you very much, first of all, Oliver, for having me in this podcast. I'm super excited about it. As you rightly introduced, I'm a very passionate person around digital as a topic and a domain. And as I was doing digital, the operations and the digital automations, marketing automations, and everything around digital, I realized around 10 years ago, it's kind of an epiphany, right? I realized that everything is leading to data analytics. So around 9 to 10 years ago, I took a pivot, and I was in a very nice, cushy job, to be honest, in the digital space. I dramatically took a change, and this is something like a cue for others who want to make the shift as well. I was moving into analytics 10 years ago, and I was very new. I had very basic understanding. So there are only two ways to learn analytics. One is to go to the schools, universities, and all these courses. And the other way is to really go through the grind. So I literally jumped into the field, took up a very challenging role running analytics teams. So it pushed me to learn more. And as I learned more, I became an academician as well. So I started teaching for the last 4 years or so. I've been teaching across different universities. And this is more than job for me. It's a very passionate issue. And thank you for inviting me on this topic. I hope I can do justice.
Perfect. So, like I said, Praveen, the buzzword started a few years ago. Probably I'm thinking 2019 or probably before in the US, but in Europe where I'm located around 2019, 2018. But let's go a little back more into the mysteries of the history and talk about the origin of data science. Did it start at that buzz, era in 2020s, or could you speak to the origin of data science and evolution a bit?
It's a very good question. And so I'll go back a little bit and talk about what is science, right? And without boring your audience. So there is empirical, theoretical, computational, and now data-driven. Those are the sequence of different sciences that exist in the world today. So empirical has been in existence for, I would say, thousands of years because our forefathers, if we have to call it that way, they found out way to aggregate, collect, and find patterns in data over a period of time. Take the Mayan calendar, you take the horoscopes that were built in India, you take the Arabic and the Vedic sciences. They were all, collection of data and science around it. Then there's theoretical, which has also been in existence for thousands of years, which mostly focused on people telling and talking about different sciences. Then came the computational science, which is the modern. That's when the chips were invented, the computers were created, machines were created, the modern human evolution, if you will. And it was mostly around computational. So computational is all about taking different inputs, making the computation happen, and build, something that will help solve problems.
Right.
Then now the last 20 years or so, we're talking about data-driven solutions, and data has become very, very important. But technically, if I have to put that into perspectives and show some valid proofs that the evolution existed this way, it started somewhere in the 1960s where there was one gentleman called John Tukey. I'm hoping that I'm pronouncing his surname properly. So he came up with this concept of the whole data science. And mind you, this was like almost 2 decades before the first...
You mentioned 1960s. We're talking about 60s.
Yeah, 60s. Okay. This is almost 2 decades before the first computer came into existence. So there were no computers, there was no PC. Of course, there were some algorithms, machines built already, but that was too early, And he's the first one who spoke about data as a science. And he kind of predicted that this science is going to evolve. And as the computational power increases, this ecosystem is going to be much, much more interesting. So that's, very forward-looking, if you will. And then somewhere in the 90s is when a group of different intellectuals and professionals in this field came up with kind of a council, if you will. There's KDD and IFCS, and I don't want to give you the full form and confuse, but these were the early stages of formally collecting the thoughts around data and data-related sciences. And then somewhere in the 2000 is when the big data revolution happened, right? Large companies like Microsoft, Apple, and so on and so forth they all thought about big data as a concept. And why big data? Because there were too much of data. This is more than ever we've ever had data, right?
Yeah.
2000 is when we started
It's a
logically
boom,
collecting data, yeah. And prior to that, data was simply in manuscripts, scriptures, papers, and in someone's little typing machines and so on and so forth. So
Right.
when that got a bit more digital, big data concept came into existence. And then to your point, it was not before 2015, right? I think somewhere in 2015, people start talking about machine learning and deep learning and those kind of concepts. And mind you, machine learning, deep learning, data science, none of this is new. They've been in existence for forever. I often use this analogy as a quick reference.
Yeah.
Think about weather forecasts, right? It's been in existence forever.
Yep.
And think about our ancestors who were able to predict lunar and solar movements.
Right.
Basically, they were tracking patterns over a period of time, collecting that data, and predicting future occurrences based on data. This is all data, right? This is not like magic, or at least as much as we know, this is not aliens
all
coming.
science, yes.
This is not aliens coming and telling us. So they were using.
Who knows?
Maybe that's what I'm saying. I don't want to.
That's a topic for another day. But yes, sorry to digress.
Conspiracies.
Conspiracy theories.
But as you can imagine, that the whole science, data science, has been conceptually or theoretically or practically been in existence forever. The formalization of it happened in 2015, and there are three major triggers that made it happen. One, the computational power. Our computational power, our machine's ability to process, take input, process, and output dramatically increased.
Right.
And the second was the intervention of cloud. When cloud came into existence and cloud became a big thing, now suddenly you're able to do everything, everywhere, all at once.
Yeah.
Literally, I don't mean to quote the movie here, but literally everything was in one place in cloud. So, and the third piece is that I think as a community of individuals, right, like you and I and many of us in the professional field today, we all were much more comfortable with using a laptop.
Right.
Suddenly from using typewriters and ledgers and books,
Right.
we suddenly are into computer. Everybody is comfortable using a laptop. I don't think 20 years ago anybody would have guessed that all our jobs would be focused on sitting in front of a laptop and working on it. And people getting the kind of money they're getting today just to sit in front of a computer. So I think these things dramatically change the way data science as a concept evolved.
Right.
So that's
fascinating.
It is.
How fascinating. So like you rightly mentioned, the way we consume data science now started around 2015, 2020. And in this space where I come from, and from a corporate world, in an IT industry, a part of my role, big part of my role, is to hire the right talent in a BI analytics data science space. So because it's a relatively new field, like I mentioned, not going back to 60s, but we only started to play in this field in 2020, and it was thrown upon us as managers, right? So forget about hiring or identifying the right talent and having a cheat sheet of good questions to ask in the interviews. I think we often struggle to write the job description. So if I'm thinking of hiring a data scientist, what are those skill sets? And let me just put it very simple. Who is a data scientist? How would you define a data scientist role? And then I'll have another question related to that, which
Divya, I might be partially controversial here because some of it is my personal opinion and some of it is what industry says. For me, there is no one role as a data scientist, right? If anyone claims to be a data scientist, I think they are maybe oversimplifying the role itself. Because data science involves different streams. It involves different specialities, right? There's data engineering, there's a data analyst, there's a data architect, there's also a BI analyst. There's so many different roles that goes into data science. And often, and maybe that's what your follow-up question could be, is there's also confusion between who's a data scientist versus a machine learning expert, right? They're two different sciences, they're two different departments, they're two different functions. The most common challenge I see, to your point, as you rightly pointed out, is how you write down the job description, right? People often write down job descriptions from two different angles. One, what they think they know. Second, what others have told them is the right way to write it. So both these approaches are wrong.
Totally agree.
So when you use both these approaches, your job description is going to be a little bit hazy, not so clear. So there are three parties involved in any job, right? One is the hiring manager, the recruiter or the HR talent, and then the actual people who are applying for it. There's always a dissonance between these three.
Right.
And another statement I'm going to make, which is possibly a little bit controversial, Divya, so bear with me. There's also a misconception that all data scientists are PhDs and they're all statisticians. They're all come from this extremely academically inclined background. I personally would challenge it in many ways, but to simplify it, a data science is a very broad spectrum.
Yeah.
You have to really be very specific about the type of role you're picking within data science. As I mentioned, a data engineer is someone who's going to go find data, use infrastructure around the data, collect, gather, synthesize, harmonize data, right? That data engineer does that. And then you have the actual data science model developers or statisticians, as we call them. They use empirical statistical knowledge to build algorithms that will drive your models or build your models into a data science ecosystem.
So, sorry to interrupt you. Is data engineer an upstream to a data scientist role? How does it fit into? Is it like a milestone towards growing, evolving into data scientist, or is it vice versa? Because I see a whole lot of data engineers, pool of talent around, and it looks like a lot of them could be aspiring to become data scientists. Is that a path that you see, or am I reading it backwards?
No, I think it's a very interesting question again. Bear with me again. I'm going to make some controversial statements here. I think data engineers they require a completely different skill set.
Right.
They have to be comfortable working with data. They have to be more structured, organized, systematic, right? It's more process methodology driven. Whereas somebody who's building, say, an analytical model or a machine learning model or algorithm, whatever you want to call it, has to be very experimentative. They need to build on hypotheses. They need to come up with hypotheses. They need to identify data nuggets that evolve that hypothesis into a practical model. So the mindset required, the skill set and background required, the experience required is very different.
Okay.
Then you have these BI analysts, they are basically who are building visualization or creating the data layers under the visualization. They have a completely different skill set. They need to be a little bit artistic, building those visuals.
Yeah.
And then there are data analysts, and folks who are working on business analysis and converting those insights into something more meaningful for the audience to consume. They need to have a completely different skill set. Right. They need to know how to interact with stakeholders, simplify business questions into data questions, analytics questions, and vice versa. So as you can see, all these roles are very different.
Very different. And my observation, correct me if I'm wrong, one of the key, when I look at a few data engineers that I know and data scientists in action, one of the key differentiators I have noticed, besides the technical skill set, is a data engineer, they love to work like a software engineer. They love to work in silos. They do not like to collaborate with stakeholders or present or communicate, which is all great. I mean, that's the scope of the role. Whereas data scientists, I think the nature of the job is they have a PM element to it. They should be comfortable handling ambiguity. They should have this passion to dig deep into data. And then the whole part around, once you've built the model, go and present to the stakeholder and convince them on the value of that model, right? So there's a bit of a comfort, or the talent that I probably would look for in a data scientist is how well you can work both in an individual defined role and also in a team collaborative role and handling stakeholders. Because I might be controversial here, but I think data engineers would love to avoid the stakeholders, whereas data scientists should not. Am I right?
Yeah, you're pretty close. And in fact, if you find data scientists who can do the business translation and work with business stakeholders, let me know. We want to hire more of those people. You're spot on. Unicorn, the true effective data scientists are unicorns. Now, which is why the market has so much of demand for them, and which is where the whole confusion around how a person calls himself or herself as a data scientist, it's a big confusion there.
Right.
To put that into perspective, and this is my personal research, so we obviously, as part of my company, Course 5, we hire a lot of data scientists and a lot of data engineers and so on and so forth. I was specifically looking for data scientists in the Europe region. We were finding it very difficult. Quite a few interviews, people claim to be data scientists on paper, but when they come on to the interview, they obviously are not able to answer some of the fundamentals of data science.
Right.
So I took it upon myself to figure out, okay, are there really true data scientists in the market? So I went with my criteria, right? Someone who has a statistical background, someone who can, to your point, be able to convert those business problem statements or opportunity statements into data science programs or hypotheses, whatever you want to call it. I could just come up with less than 100 individuals
Yeah.
in all of Europe whom I would categorize as data scientists, and still may not be 100% data scientists, but someone I believe are data scientists in my
If we
personal
have to put a number to like how many data scientists, according to this definition, full stack data scientists
Less than
exist in
100.
Europe?
Less than 100. And of
Wow.
course, people can challenge me personally. Please do contact me and I'll show you my data points. But the fact is, there are less than 100. So what happens when the demand is high and the actual numbers are low, then that's where the whole confusion
Yeah.
comes up.
Right.
People, the data engineers who have done a little bit of more analysis or been in the stakeholder fronting roles claim themselves to be data scientists. And many others who are doing BI or regular business analyst kind of a work. Again, I'm not kind of, trivializing anyone's role. Everyone's role in this ecosystem of data science is extremely important. Without a great data engineer, a data scientist cannot really do a lot. Without a great business analyst or a BI analyst, your data science projects are never going to be successful. So all these roles are independently important, but people having that confusion on what this role really means has created so many profiles in the market who claim to be data scientists. And there are also individuals who are doing data science, knowingly or unknowingly, categorizing themselves as data engineers because that's what they do in bulk.
Right.
And to put that into perspectives, data engineering is a massive exercise. It takes a lot of time.
I have huge respect for data engineers
Absolutely.
because none of these roles are ranked or should be ranked above each other. They're all complementary and extremely critical. I would go to the extent of saying we need, while we are building, and especially organizations where we're still building our data maturity and infrastructure, we need data engineers. They are like smart bunch of people. And then data scientists could come into play and take it over from there. And then they work, mutually once you launch a model, when there are business changes, variables and all that. But one thing that I wanted to get your perspective on is when you are starting a team, which is, a BI analytics kind of function, you're not a part of a whole bigger support function, but you're within a business, and your stakeholders expect you to deliver advanced analytics, applying a whole lot of these data science tools and solutions. Should we just look at hiring, I don't want to say good enough data scientists, but let's say a partial data science who has more of pipeline building and data engineering skills, and rather than looking for like unicorn, full stack data scientists with experience on in statistical tools and coding and everything. It's like a startup, right? When everyone has to wear multiple hats. So do you think it's the right approach to focus more on data engineers who have the potential to further move into data scientists, or have both but not look at hiring the creme de la creme of everyone? Does it make sense?
Yeah, completely. It makes sense. So I think to just go a little bit backwards on that. First of all, you're not going to find those unicorns easily, and even if you do, you're not going to retain them. And if you manage to retain them, there's a possibility that the outcomes coming out of those individuals are going to be effective and impactful. Because we're talking about a handful of people for, say, a multi-billion-dollar organization. You're talking about a handful of people who are actually putting their science into something. It's like, you go to these scientists in other disciplines, like, the physicists and the other types of scientists, if you will. They have a very clear demarcation on what they specialize on.
Right.
I think this industry needs that unified clarity on what these roles are.
Yeah.
That's the first part of my response to your question. The second part is around how the organization structure should look like. You could obviously create a structure that makes sense to your business. I think the tricky part here is going to be how you're going to experiment with the combination of resources. If you take the volume of work into account, then you need data engineers and you need a lot of people who are creating those pipes and gathering data, integrating data systems, putting them in a singular view and converting them into tables and so on and so forth, right? That's a very voluminous and heavy duty lift and pull kind of work. So you can maybe you would be tend to thinking of putting your priorities there, right? The other way of looking at it is, what is the end outcome you're trying to get out of this exercise? So if the team that you're building is exclusively supporting your business unit or business function, then you bringing any data scientist is not going to help. I'll tell you why though. And this is something that is also very interesting and important is, not any data scientist can work in any type of data seamlessly. let me put it into perspectives. You're into tech industry. There is CPG, there is pharma, and there's so many different industry. If you just look at the data attributes and variables flowing into a model, they're going to be very domain and also industry specific.
Right.
So if you bring a data scientist who's been building and working in data science ecosystem for a CPG industry into a tech industry, that person is not going to be seamlessly fitting into your organization.
Right.
Because the data attributes, variables, nuances, and the business and industry nuances are going to be so different for the data scientist to come up with that hypothetical or hypothesis, if you will, right?
Yeah.
The inferences that person is going to make is going to be very critical for your outcome. I know it's a very long response to your question.
No, that's good. So do you think the job markets have pivoted into like over glorification of this role of data scientist?
I think it's a function of two things. One, everybody wanting to be part of the race. They don't care whether they win the race or not. They just want to be part of the race. I mean, I use it with with a pinch of salt here because, again, these are very controversial statements, right? Business leaders today tend to be part of the bus rather than part of the true requirement for that function. So I've obviously worked with many smart leaders. And one of the common things all these smart, very successful leaders in delivering analytics, if you will, they might personally may not be analytical experts or who have done data science or who understand this end to end, but they do one thing really smart. They identify valuable outcomes that they want to achieve out of this exercise, right? And their mandates are not building teams, but their mandates are building solutions. So the mindset kind of flips suddenly. So if you look at if somebody comes and gives you a budget of say $1 million and say, Divya, go build an analytics team, how would you prioritize that $1 million, right? You would possibly look at it from the traditional team building exercise and say, okay, in a typical analytics team, I need a couple of data scientists, I need a few data engineers, I need a few BI analysts, and so on and so forth. You traditionally look at it that way. I would maybe do it in a very different way. I'll see what is the expectation for this $1 million investment. But the most important thing that you have to set as an expectation with your leaders is you're going to experiment. This is what is missing.
Yeah.
All the successful leaders that I know and I've worked with in the analytics space who are successful in delivering analytics are extremely experimentative. They use vendors, partners, internal teams in experimentation, co-innovation. That is going to be, that in my opinion, that is the theme you should go with your investments on.
Yeah.
Not really creating a traditional team structure, but actually creating that co-innovation ecosystem. And obviously, the second part to this is build versus buy. If you try to build everything in-house, it's going to be time-consuming and possibly not seeing the light, right? But if you build and buy depending upon where your organization's strengths and weaknesses in terms of that portfolio of resources required for you to drive that analytical solution, is going to be critical as well. So that I know it's a very long response, but it does.
And I think also it's important that we set the right expectations with the leaders and the stakeholders on how it works, because often, the executives and the leadership, they know that as an org, a big org, we are very good at retrieving the data, storing the data. We have everything, state of the art. But when we want to apply data science, there is an aspect of whole, it will take time. We're going to experiment because we're all at a very rudimentary stage in terms of maturity when it comes to application of data science solutions, right? So that expectation needs to be clarified, because I think often one could miss that because business stakeholders do not have typically data science background, right? Yep. So that is very important, patience and, the fact that we are going to experiment, and the fact that, yes, we have a huge, we're good at, storing our data, retrieving our data, but still there's a lot of data and there could be a lot of mess on that data in the way we want to provide the solution, right? You kind of answered, a bit to my next question, but I'll ask anyways to see if we missed anything. What, people who are managing teams of data scientists and data analytics BI team, what should business stakeholders without that background do to stay abreast, to fill that knowledge gap or whatever, what do you suggest?
Right. Again, a very important question. And this is where we all have to come into the same page. Yeah. We all have to accept the fact. None of us, I didn't start in analytics with any a strong analytical background. I'm neither a statistician, I'm neither a data engineer, none of those, right? My journey was very difficult. I had to struggle a lot. I think to answer your question very directly, the only and the best way to get through the journey is by first realizing and accepting where you stand in the analytics space. For that, you need to have some introspection personally and also talk to some of the experts in the market, your peers in the organization who are doing this very well. Identify those leaders in your community who are successful in the analytics space and consult with them. That's the first step I would do before jumping into a course or taking up online videos and so on and so forth. Because as we were discussing earlier, there's so many disciplines in analytics. You can't be an expert in all those disciplines. And if you pick any one of those and go deep into it and try to understand them, you might not be able to practically apply that. You might be spending a lot of time. So first step, understand where you stand from your personal understanding of what your maturity levels are in analytics. Number two, have as many people as possible in your community, in your network who are in this space and doing successfully something related to analytics and consult with them, right? The third is try to get as much knowledge as possible with publicly available information. Before you sign up for any courses, spend that money, as
LinkedIn and resources available.
YouTube, for all it's worth, YouTube has massive amount of content and there are a few specific channels that are very good at curating this information for free. So start going through those content. And what happens when you start going through the content is you'll be able to figure it out. You'll be like, okay, I understand these, I don't understand these. Then you will know what you understand and what you don't understand. Then you will be able to you'll be more focused on getting into the right kind of course.
So, but let me ask you, sorry, but there are some self-proclaimed 3 to 6 month boot camp course that teach you data science. Do you think 6 months is a good enough time? No, I have to clarify. This question is more from someone who wants to become a data scientist or aspires to build a career, not as a manager or a stakeholder, but when you mentioned YouTube, this question came to my mind. These bootcamp courses, and 6 months, is it enough for someone who wants to dab into data science?
Divya, have you heard about the 21-hour theory? There's a theory that says that you can learn anything in 21 hours. Any skill set in 21 hours. I'll not go into the science behind it. So there's a big difference between learning and actually putting it to use. If your goal is to just understand the concepts, and learn those concepts so that, when somebody at business or at work or in your other community conversations, people are talking about it and you want to know what they're talking about it, then these courses are not bad. They can help you contextually connect the dots.
Right.
But as I said, learning is very different from implementing and actually executing on analytics.
Right.
If your goal is to be an execution-heavy leader who's able to also run teams that are executing, then you need to go through a different drill altogether.
Right.
These boot camps can give you perspectives, but it cannot train you for the real world.
Yeah, which it is very individual, and one could do the boot camp and then through practical application, and if you have an org where the stakeholders are willing to spend their time and experiment, I think that could be a helpful 6 months course, because the rest of the learning could be through actual, jumping in the pool and learning to swim.
Yeah, I use this analogy all the time when people ask me this question. 10, 15 years ago, the huge buzz was executive MBAs, online MBAs, online PhDs, online doctorate programs. And what happened to all of those is that everybody got into it. And suddenly, LinkedIn is flooded with MBAs. LinkedIn is flooded with doctorates in certain sciences and discipline. Does it really add value back to you? It's a nice thing to have on LinkedIn, but is it really adding value for your business?
Point, yes.
Would a recruiter, would a large company hire you because you've done an online MBA or an online data science course? Definitely not. If I'm a hiring manager, if I'm hiring a data scientist or any of those disciplines within the data science, someone who has done a 6-month, 8-month boot camp is a good trainee analyst for me, but not a manager or not an execution specialist, not a consultant, because they will not be able to do that. So I'm going to still count their core experience within the discipline rather than the courses they've done. So if your intent is to learn and be clear about the references around the topic, go for these courses.
Okay.
But for you to become a proper, any of these roles within data science, you have to go back to the learning mode. As I mentioned, I did that. I was in a very comfortable digital profile job where I could have further accelerated there. But I took a step down, I downgraded myself, went back into the field, I became a trainee in my own perspective, right? I became a trainee. I downgraded my expectations from the role so that I can learn it from scratch.
Right.
And I still haven't learned it. I still am not there yet, even though I teach and talk about it.
Yeah.
I will never claim myself to be a data scientist. I'll never claim myself to be a proper data engineer. So the learning process is yours. And there's another piece that you need to understand. True data science or the core data science involves a lot of empirical statistical knowledge, right? Building those models, algorithms requires a lot of statistical knowledge. And we all know maths and statistics is not everyone's game. So you should know what your strengths and weaknesses are.
Yes.
If you're going to assume that overnight I'm going to learn statistics and build models, that's a long journey.
Absolutely. So a few minutes back, you mentioned different elements of data science and terms like machine learning, ML, deep learning, AI. I mean, often we tend to confuse with these terms, and we use it incorrectly as synonyms and interchangeably. So can you clarify the confusion between data science and machine learning, and then also help us understand where AI, ML, deep learning fits into all this?
Sure. First thing first, data science and AI are two different disciplines. They do have overlaps. They do have some sort of midpoints where they interact, and there's a lot of connections between them, but they're two different disciplines. And we have to be very clear in our minds, data science and AI are two different disciplines, right? Data science as a science describes generating, collecting, building, integrating, harvesting, synthesizing, processing, and then leveraging that for decisioning and other pieces. Now, AI, and let's keep AI out of conversation for a minute because there's a lot of confusion on AI. Machine learning is more algorithmic. It's more about a machine learning patterns and making decisions on behalf of a human, if you will, right? So machine learning as a discipline requires a very different skill set. By the way, not many people know that machine learning has so many different disciplines and roles as well. The roles we spoke of, data engineers and all those things, don't apply in the machine learning world. They consume these services, but they're not. So the roles are very different. There are machine learning architects, there are machine learning engineers, there are AI architects. The roles are completely different, which is why when somebody comes to me and says that I've done machine learning, and I ask them, what did you do in machine learning? They said, I built certain automation engines. And I would be like, okay, what did the automation engine do for you? It basically tracked repetitive actions, repetitive tasks, repetitive intuits, and converted them into some sort of a logical output. But that's not machine learning technically, right? So people are still confused what these terms mean. And now comes the AI part. This is where, again, bear with me if I'm controversial, but this is my fun conversation to have. And I hope you can have a conspiracy theory session later.
We love conspiracy theories, and we all love good controversial statements. So go for it.
True AI, in my opinion, exists in such small pockets that people hardly come across them. It's a massive superset. You're asking a machine to behave like human and have cognitive powers to take decisions, respond, and do everything. I often see this. Oh, we have a bot that is AI-led bot. I look at them, it's algorithmic, right? It's taking a decision tree process to selectively send you responses based on your input. It's querying its database, it's querying its logic, it's querying its training data to come up with a response. Is that truly AI? Maybe not, right? So I will keep AI separately. And, AI and machine learning are also loosely used. And deep learning, when it comes to deep learning, everybody talks about neural, everybody talks about having multiple nodal connections that bring data back and query the data back and query the patterns back and provide insights. They're very different disciplines. So it's AI, machine learning, and deep learning, right? They all feed in that sequence, if you will. So that confusion, I want to, again, just to summarize it as, if we are using AI as a core theme for a solution or a product, it better be AI, right? Otherwise, you can use other ways to reference them, and let's not make it a buzzword. My sincere request to all the business folks out there, people who are into this domain and discipline is, let's not create a confused state of mind amongst our youngsters and next generation, because they're all, I know of so many youngsters who want to be AI specialists, machine learning specialists. We're creating a dissonance for them where they believe them creating a repetitive pattern-led algorithm is AI, right? that is not the case. So that's my take on it. It's more of a statement than a
No,
response to
absolutely,
you.
and well noted. And I hope people who are watching and listening in roles of business stakeholders and managers would make a note of it as well.
Expect some backlashes though.
Ready for it? Talking about automation, AI, all of this. Auto ML. What is it, and will it take away the role of data scientist in future, considering it could automate everything? What's your take on that?
So let's understand.
Let's make our audience who are data scientists a little bit relieved. I'm hoping the answer is going to be a positive one. But
Absolutely. There is no replacement of human intelligence and cognitive abilities. No matter how sophisticated our machines are going to evolve over a period of time, the whole Elon Musk statement that AI is going to take over the world is possible. I'm not going to take that statement away. But the reality is that we are a few generations away from it.
Yeah.
And I think we as humans beings, how did humans evolve the food chain, if you will, and we became, even though we're physically and structurally, anatomically not dominant as other species on the earth, but we are the most dominant species today, ecologically and structurally.
Right.
Why? Is because of our ability to think and our cognitive abilities. While machines can do that faster and more complex than us,
right.
the core decisioning is still with us. So none of these core human requirements are going to go away anytime soon.
The scope might change
might
or
change.
evolve.
Absolutely.
Like it's a funny example is if you look at accountants.
Yeah.
Very, very prestigious and very credit role. My huge respect. Can't live without the good accountants, right? But theoretically, the role of an accountant, if you look at from the last 20 years, could have been easily automated, right? But they're still there, and they're still,
you need them
budding, and the roles have not gone, right?
Yeah.
So yeah, I agree. I if we have a little more time, I have a few bonus questions. I know you have to catch a flight, but. And these questions have been in my mind through various conversation, and I was contemplating to talk about this with the subject matter experts in this field. You hear statements like, even the big organizations, the leaders into data science space, are not always able to crack it. We are still so new. Most of them are like faking it till making it kind of thing. Is it true that 1 in 10 or 1 in 5 or whatever number projects in data science are not able to reach into production and they fail? Like, what is you work with
yes.
that area more than.
This is a tricky question, Divya. Okay? You're challenging my core job profile right now, so this is going to be very tricky to answer. But I'll put it in a
for
slightly...
the sake of I think this is in the good. How do you say? In the spirit of the teacher in you, or the clarity for the welfare of the society. If you could just throw some light on this.
I think every smart leader has realized that analytics, data science, machine learning is going to eventually accelerate their business, right? They also clearly understand that they're not necessarily the most knowledgeable or knowledge person in this ecosystem. But functionally speaking, we all are trying to move towards something that is going to be futuristic in nature. Yeah. So if you keep that theme in mind, I think we're good.
Okay.
We don't have to overcomplicate this. You don't have to over...
right.
I don't know if I answered that question.
No, I get it. I just, it was in my head, so I just wanted to take a quick take from you on this one. One thing that I wanted to ask, when you look at, you mentioned earlier that if a true data scientist should be able to do comfortably coding or a bit of programming. You probably didn't mention coding, but you talked about good with or not good with statistics, maths, and then a bit of coding. But I'm trying to find a good distribution. Like, is it 50% of coding and 50% of maths and statistics, or is it 60-40? Do you have kind of a suggestion?
I have a very rude answer for you.
Okay.
100% intelligent. Because the combination you're asking for is very specific to the programs you're going to run, very specific to the business function you're going to support. I think one of the most important criteria I look for when I'm hiring for people in the space is how quickly they can learn something new, how adaptable they are in terms of building knowledge very quickly. So I know data scientists who come from psychology background, nothing to do with statistics and numbers. They're of course PhDs and they're of course extremely educated, but the core requirement there, ability to learn quickly, ability to process information quickly, and ability to translate that process information into meaningful insights to the organization. As long as you have this core ability to learn and build out, it's always going to be a work in progress. For example, you might have seen this on LinkedIn and many forums that learn Python in 2 weeks, learn R and Python in a month. And the reality is you can learn them in a month or so, right? The core coding programming languages are so well defined with open source and all other support systems out there. They're very much structured. Learning them is not going to be very complex as long as you put your mind and merit into it. As I mentioned earlier, applying that with intelligence is the skill set that you really, really need. And which is why many tend to go to the PhDs. Why the PhDs are popular data scientists across the globe is the fact that once you've done a PhD, it establishes 3 things as an individual for you. 1, you're generally smart and intelligent. 2nd, you have the patience to learn something new. 3rd, you're able to give your dedicated time, not just from a patient's point of view, but from also a focus point of view to get the outcome out of it. That's why you go to the PhDs, because they have the basic intuitive nature to go through that experimentative process of being a data scientist. So
that's very well said. So basically, if we are thinking of who is an ideal data scientist, is someone who loves the job of a data scientist, who is I would say, who can deal with ambiguity, because there's so much of ambiguity in the data. Still would think that who loves simple statistics, who can code. And like you just mentioned, all about PhD and all, but basically someone who loves to be the detective and learn and explore. And then also be comfortable dealing with people and stakeholders, right? So that's, for me, an ideal candidate or potential.
Sorry to interrupt. You missed one more thing. Someone is okay with failures.
Absolutely.
Someone is okay with quick failures and long-term successful outcomes.
Yeah, kind of. Yeah, when you're comfortable dealing with ambiguity, you kind of are okay with the frustration that comes along. And yes, you're right. It's you're prepared and you're okay with dealing with failures. But yeah, thanks for pointing that out. So we can go on and on. This is such a topic, but I know we have a time constraint. Just wanted to summarize, and let me know if I got it right. Like I just summarized my perception based on what we discussed, the role of a data scientist, or who could love being a data scientist, as we just spoke about. But also going back to the buzzword and the hype, that if people are thinking if data science is a hype, I think like any innovation, it goes through a hype cycle, right? When internet came into place and everything, be it a lawyer's profession or any kind of a big innovation that brings, it's disruptive in nature, has a hype cycle. I think data science is going through that, and probably we are at the end of it where the hype is going to settle and we are ready to, the data science is ready to, have its stable feet and go ahead and make all those changes and contribute to every sector industry, but also human mankind, like, genomics and healthcare. So I think it is rightly a buzzword because there's a lot of buzz that was created. It's also a hype, but it's not for nothing. I mean, the hype cycle goes, it's like I said. And I hope this conversation will be helpful for those who have had similar questions that we discussed. It was great chatting with you, Praveen. Thank you so much. I really appreciate it. And I hope we can do this some other time and have more questions on some of the things that we didn't touch today.
No, it was lovely talking to you, Divya. This was a very interesting conversation for me. I think your questions were very smart and quirky as well. So thank you for making this very entertaining for me as well. So
thank you for watching and listening. If you like this conversation, please do not hesitate to like, subscribe, and leave your comments. Have a nice day.